but the game theoretic approach for companies, businesses like firm A versus firm B in a two-player zero-sum game. You have company A versus B. Like A is like offense on the offense, B is on the defense. What B wants to do, being on the defense, wants to minimize its losses, and A wants to maximize its gains. So there's a minimax thing here going on, and we don't have time for that. You can study it. It's in the paper. It's in the well, this will be on the web too. You can look at it. But in the long run, what they want to do is they want to have a strategy of, what to do about advertising, quantity discounts, and extended warranty, so that B on the defensive can minimize his loss. And so you can take that B to be like our defense against vulnerabilities, threats, and hackers and crackers and all those bad guys. B is the countermeasure. B is the countermeasure. A is the bad guys. So, and you do this in a business environment, and you get the results. You come up with a solution. Now, in a risk adversarial problem, where you can see that on the left side we have the defensive stockpile, biosurveillance, first responders, mass inoculation. In the payoff matrix, a smallpox example that Duke University carried some few years, well, about 8-10 years back during the anthrax problem, or something similar to that. And these are solutions, countermeasures: no attack, minor attack, major attack. So you see the columns are defense and rows are offensive. The history of game theory, and today, it all started in almost 100 years ago by von Neumann and others, Nash from the Beautiful Mind, and Auburn. And so U.S. in all these studies wants to pick the defense with the smallest row-wise maximum, and terrorist picks the attack with the largest column-wise maximum. Yeah. How do we adapt this idea to our security meter? You can see that on the left we have vulnerabilities and threats and as rows, and columns are countermeasures. I cannot control vulnerabilities and threats. They come from the enemies or from the nature. I can control my countermeasures. So, and this whole matrix that you see here is innovative. It hasn't been done before. This is what is the core of the problem here for the game theory approach, and it's like the Coke formula, as they say. So, what happens is when you bring the matrix, the game theoretical matrix into this format, and then you want to put it into your, you want to apply the optimization techniques like linear or nonlinear programming techniques. So, and after you do this linear, nonlinear, you end up with a new countermeasure result. So here is a result that you see from a security meter table. On the left, you have your base server. On the right, you have improved server. All right, so what we did, we went from 26% down to 10%. Well, who did this? Well, I mean, game theory was instrumental here in picking what changes where. So changes in the first leg, and sometime later on another leg here. So these changes add up to 90% change, 0.9 out of 1 out of 100. This is the least change you can get. This is the optimal amount of change for the money's worth. So you went from an $833 expected cost loss down to $320 cost loss, and in between, you lowered your expected cost of loss by $513. Where did that money go? That money went to spending these on the right, on the cost column, to companies which will cater for you, which will give you the service to reduce your cost from a 26% to that 10%. So this is optimization process. We will elaborate on that in a demo format just very soon. Now, we also can do nonlinear minimization of the portfolio variance. Statistically speaking, we can do variance approach now and follow Markowitz nonlinear optimization solution using Lingo software. Now, Markowitz won a Nobel Award, a Nobel laureate. He was a Nobel laureate. He was a Nobel Prize for his techniques in economics, but he couldn't have won one for this study because his Markowitz application to portfolio approach by us in this study gave worse results than the linear optimization. So not everything has to be, fitting everybody else just because his economics, problems gave good results. So in there we have 309% as opposed to 90%. So nonlinear portfolio risk table did not give me good results. I was checking that. I had 90.5% change as opposed to 309% change. So which one is better? Obviously, the game theory linear programming that I came up with is far better than the portfolio nonlinear Markowitz approach. So I just wanted to check this in case I didn't try out my other chances. So I'm going to do some applications on this and show you a demo. And so what we're doing is we have a cost. We were trying to optimize the cost effort to countermeasure, to optimize the countermeasure against the common enemies, such as hackers, crackers, viruses, horses, and worms, and cobras. Well, you've never heard of Cobra. It's a new strangler virus. Need antivenom software. Don't believe that. Cobra is not a new virus. It's a joke because people are coming with all these new names of cobras and things and does this and that. So anyway, but you never surprised. After I do this, by just hearsay, and you'll have in a year a new virus which is named Cobra. You never know. But for the time being, it doesn't exist. So when you do all this study, security meter, and come up with results, you will see that at the end of the study, not only, like I showed you before, not only you'll get the base server and improved server, but you'll also get a bunch of advices on the right. How to do what in order to reduce from 26% originally to 10%. What you're doing is, as a user, if you were at home sitting and you have these programs, for example, as a product that came in front of you one day, you never know, as a product, and you can optimize your risk from the already existing bad to the good what you desire for amount of money you want to spend and what to do about it. I will show you the demo. Now, further research here, I'm going to show you how to run this program and show you that a common user who doesn't have to know all that part, most of you may be well learned in computers or internet, but some of the people at home are using this just to email friends and to their friends. And so, but if they have problems, they don't have money at this time to go and repair it. What can they do about it? So I will show you how to run this program, how to do that, and we'll apply a few domains. Like we'll look at the security problem, we'll look at the privacy problem. These are the two pillars of trustworthy computing. I'm working on now e-voting, eco-risk, and wireless. As a matter of fact, usability is the next step that we want to work on. Now, so what do I mean by security risk tree diagram? You've seen the simple ones I've shown you earlier, but here's a very complicated looking, actually all around hardware, network, environment, web applications. It took us months and months to come up with this study. It's not like overnight and you just go there and pick up something up in the air. So these are not final. A company, like I go to a bank and bank wants to change this. He wants to add his own. They want to add their own vulnerabilities and threats or countermeasures. They can do so. I have another mobile external intervention program which I'll show you, which kind of keeps the privacy, preserves the privacy within the company without me as an analyst getting involved. So this is security risk diagram. You see all kinds of possibilities. And then you have the privacy risk tree diagram. So I want to also study the privacy, which is a different pillar. You see, according to the new definition, there are 4 pillars of the trustworthy computing. That's privacy, security, reliability, and usability. And Microsoft also included business practices. Now, there's another one I recently started working on, e-voting risk tree diagram. I've been told that Purdue CERIAS does have some work going on in e-voting. So that came up after the elections. For example, I went to the election site and I was supposed to vote, and they couldn't find my name, last name, first name, and my last name, first name were all mixed up. And my family was there before. I said, "What's wrong?" So I went and saw that they mixed it up because they didn't know too well Turkish. So so that they don't have to. But so these are all problems. Like anyway, at the end, you can work with these